Hi, everybody, and welcome to Backer Breaks It Down. In this episode, we're going to take a closer look at rate of change, and we're going to look at how can we use the average rate of change to make predictions. Okay, so remember, we can find average rate of change by finding the change in our y values with respect to the change in our x values. Basically finding the slope of a line, but we call it average rate of change because, well, all functions have an average rate of change. So in the table here, we are given information about the perception, reaction, time, distance, and that's the distance a vehicle travels after it sees a hazard and applies the brakes to when it stops. Okay. And so Part A wants us to find the average rate of change of the distance over the interval from 30 is less than or equal to m is less than or equal to 40. So 30 and 40, that's corresponding to the miles per hour. So when the vehicle is traveling at 30 miles per hour, it's that distance it travels upon seeing the hazard is 61.6 feet. And then traveling at 40 miles per hour, the distance is 82.13 feet. So I want to use my average rate of change formula, and I want to calculate the average rate of change using these values. Okay. So I did that. All right. I know I'm super fast. So I got the average rate of change to be 2.053. So what does this mean? So this means for every 1 mile per hour increase, the distance that the vehicle travels increases by 2.053 feet for each one of those miles per hour. Okay, that's what it's doing on average in this interval. Okay, so because I know that it's increasing by 2.053 feet for every mile per hour increase, I can use this to make predictions for any speed in that interval. So part C says use the average rate of change to estimate f of 36. Well, 36 miles per hour isn't on the table, but it is somewhere in between the 30 and 40 mile per hour range, which means that the distance at 36 miles per hour is somewhere in between 61.6 and 82.13 feet. I know that. I know it's somewhere in between there. Okay. So what I can do is I can take something that I know. For instance, the function at 30 miles per hour. I know that at 30 miles per hour, the distance is 61.6. Right? But I don't want 30 miles per hour. I want 36 miles per hour. So that's an additional 6 miles per hour, right? And each of those is increasing by 2.053 feet. Okay. So I can add those 6 additional 2.053 feet to what it was at 30 miles per hour. Okay. I'm essentially filling in the table. I could continuously add 2.053, 2.053, and so on until I got to 36 miles per hour, or I can use multiplication. And so I'm getting 73.918 feet. Okay. So I'm basically filling in the missing parts of the table. Okay. And so I can use this idea to make additional predictions here. Part D asks, how would you estimate the perception, reaction, time, distance of a vehicle traveling 64 miles per hour? Okay. Well, 64 miles per hour does go beyond the table. So maybe I would want to find the average rate of change for the entire interval. And then I'm going to take the function at 60 and add to it 4 more, because 60 plus 4 is 64, times whatever the average rate of change happens to be. Because maybe I think it makes more sense to use the average rate of change of the entire interval. You could still use the average rate of change from part A. I mean, that would work. Okay. Because it asks, how would you estimate that perception reaction time? Okay. So average rate of change, in addition to being something we can use to make predictions about future values, it can also tell us whether or not our function is increasing or decreasing. Yeah, I could totally look at a graph and see, oh, the function is increasing here and it's decreasing there. But I can also use average rate of change. So when it comes to like an overall increasing function, the average rate of change is positive on the interval. For a decreasing function, you're going to see that the average rate of change is negative on the interval. Okay, so that's why in the previous problem, when I calculated a positive average rate of change, I said that like the distance was increasing because the average rate of change was positive. Okay, so in problem number 3, it says find the average rate of change of f for -3 is less than or equal to x is less than or equal to 2. So this is an x value, -3. It corresponds to the point -3, 2. The x value of 2 corresponds to the point 2, 1. So I want to use those 2 points when I calculate my average rate of change. Okay, and remember, I'm simply using what I know to be the slope formula to find average rate of change. So y2 is 1, y1 is 2. So 1 minus 2 divided by 2 minus -3. And that gives me -1/5. So I can say that on the interval from -3 to 2, the function is decreasing on average. Okay, clearly it's doing, if you look at the graph, it's like decreasing and it's increasing, but on average, it's decreasing. Speaking of those increasing, decreasing intervals, 4 and 5 are asking for just that. So when we do interval notation for increasing and decreasing, we want to use x values, okay? So I'm just going to make some little side notes at the bottom here. So we're going to use x values, and we're going to use parentheses, okay? So like in parentheses, you're going to have your 2 x values. So you'll have the x value where the interval starts, comma, the x value where the interval ends. Okay, yeah. So let me get a highlighter because I'm going to highlight all the places where my interval is increasing. Okay, so it's increasing starting right away from the very left end until I get to -3. It's increasing again starting at -1 until I get to 2. And it's increasing again starting at 4 going to infinity and beyond. Okay, so let's write out these intervals. So whenever you want to say that like the interval starts left forever, you want to use -infinity for left forever. So it's starting left forever and it's ending right here where x is -3. Then it switches to decreasing. So it's decreasing starting at x is -3. And it stops decreasing when it gets to x is -1. And then it picks up again. I use u because it's picking up again, but u is also union in math. And that's what we use to like whenever we have like continuing intervals like this. So we picked up again at -1, and it's increasing until it gets to x is 2, and then stops increasing, picks up, again decreasing. It's decreasing starting at x is 2 until it gets to x is 4. And then it's increasing again from x is 4 to infinity and beyond. So right forever is positive infinity. So that's how you can analyze a function using average rate of change, and also, well, how you can make predictions. So we find average rate of change by calculating the difference of two outputs divided by the difference of their corresponding inputs. In other words, y2 minus y1 divided by x2 minus x1. And that's how Becker breaks it down.